0620_W23_Ms_41. 5 Methane reacts with steam to produce hydrogen gas. The reaction takes place at 1000 degrees Celsius and 100 kilopascals pressure. 5. The reaction is reversible and reaches an equilibrium in a closed system. State 2 features of an equilibrium. The rate of forward reaction equals the rate of the reverse reaction 1. The concentrations of reactants and products are no longer changing 1. 5b. State and explain, in terms of equilibrium, what happens to the concentration of hydrogen when the pressure is increased. 1. Concentration decreases 1. 2. Position of equilibrium shifts to left and fewer moles of gas on left-hand side 1. 5b. The temperature is increased. Concentration increases 1. Position of equilibrium shifts to the right and forward reaction is endothermic 1. 5b. A catalyst is used. No change 1. Catalysts do not affect position of equilibrium 1. 5c. Methane is a greenhouse gas which contributes to global warming. Name a greenhouse gas found in clean, dry air. Carbon dioxide. 5c. Explain, in terms of thermal energy, how greenhouse gases cause global warming. Greenhouse gases absorb thermal energy from the Earth 1. M2 and M3 1 mark each for any 2 of. Energy from the Sun absorbed by Earth's surface. Earth emits or reflects thermal energy. Greenhouse gases reduces or stops thermal energy loss into space. Increasing in amount of greenhouse gas results in a higher atmospheric temperature. 0620_W23_Ms_42. 5. Chemical reactions can involve transfer of thermal energy. Enthalpy change of reaction. 5b. Tetrachloromethane gas, CCl4G, reacts with steam as shown. The reaction is reversible. The forward reaction is exothermic. State what happens, if anything, to the rate of the forward reaction if the concentration of CCl4 is increased. Explain your answer in terms of collision theory. M1 rate of reaction increases 1. M2 more CCl4 particles per unit volume 1. M3 frequency of collisions between CCl4 and H2O particles increases 1. 5b. State what happens to the position of equilibrium, if anything, when the pressure is increased. Explain your answer. M1 position of equilibrium moves to left-hand side 1. M2 more gaseous moles molecules on right-hand side 1. 5b. Fig. 5.1 shows an incomplete reaction pathway diagram for the forward reaction. On Fig. 5.1, filled circle insert the formulae of the reactants and products. Filled circle draw an arrow, labeled A, to show the activation energy. Filled circle draw an arrow, labeled increment H, to show the transfer of energy in the reaction. M1 labels mark, and M2 activation E mark. Upward arrow labeled A from energy level of reactants to top of hump. M3 energy change mark. 1 downward arrow labeled H and energy change starting from E level of reactants and finishing at E level of products. 5b. IV define the term activation energy. M1 minimum energy 1. M2 that colliding particles must have to react 1. 5b. V state one way in which the activation energy of a reaction can be changed. Decreased by adding catalyst. 5c. The equation for the reaction between tetrachloromethane gas and steam can be represented as shown in Fig. 5.2. Table 5.1 shows some bond energies. Use the bond energies in Table 5.1 and the increment H value for the reaction to calculate the HCl bond energy using the following steps. Filled circle calculate the energy needed to break the bonds in the reactants. Energy needed to break bonds in reactants. M1 4x 340 plus 4x 460 equals 3200 kJ per mole 1. Filled circle calculate the energy released when the bonds in carbon dioxide form. Energy released when bond in carbon dioxide form. M2 2x 805 equals 1610 kJ per mole 1. Filled circle calculate the HCl bond energy. M3 3200 1610 plus E 4 HCl equals 130. E4HCl equals 3330-1610 equals 1720 kJ per mole 1. M4 1720. 4 equals 430 kJ per mole 1. 0620_W23_Ms_43. 3. This question is about nitrogen and some of its compounds. Nitrogen is converted into ammonia, NH3, in the Haber process. 3a. State the percentage of nitrogen in clean, dry air. 78%. 3a. State the source of hydrogen for the Haber process. Natural gas. 3a. Complete the dot and cross diagram in Fig. 3.1 for a molecule of ammonia. Show the outer shell electrons only. M1 3 single bonding pairs containing 1 dot and 1 cross 1. M2 2 dots are 2 crosses on N and no additional electrons on H's to complete the outer shell on N and all 3 H's 1. 3 IV. Write a chemical equation for the reaction occurring in the Haber process and give the typical reaction conditions. Include units where appropriate. Chemical equation, M1. Reaction conditions, M2 rightwards harpoon over leftwards harpoon 1. Temperature, M3450 degrees Celsius 1. Pressure, M4200 atmospheres 20,000 kilopascals 1. Catalyst, M5 iron 1. 3b. The first stage of this conversion uses a catalyst and occurs at a temperature of 900 degrees Celsius and a pressure of 5 atmospheres. The forward reaction is exothermic. I suggest which of the following elements is most likely to be used as a catalyst. Draw a circle around your answer. I. Platinum. 3b. State the oxidation number of nitrogen in NH3, M1-3, 1. No, M2 plus 2, 1. 3b. Use your answer to E to explain whether the nitrogen in ammonia undergoes oxidation or reduction. Oxidation and oxidation number increases. 3b. IV. Complete table 3.1 using the words increases, decreases or no change. Less than, answer. 3b. V. Decreasing the temperature causes the rate of the forward reaction to decrease. Explain, using collision theory, why the rate of the reaction is slower at the decreased temperature. M1 kinetic energy of particles is lower 1. M2 frequency of collisions between particles is lower 1. M3 fewer, lower percentage, lower proportion, lower fraction of particles have energy greater than equal to activation energy. OR. Fewer, lower percentage, lower fraction of collisions have energy greater than equal to activation energy 1. 3c. In the second stage, nitric acid is produced. Balance the symbol equation for this reaction. 0620_S23_Ms_41. 6. This question is about sulfur and compounds of sulfur. Sulfur is converted into sulfuric acid, H2SO4, by the contact process. The process involves 4 stages. Stage 1 molten sulfur is converted into sulfur dioxide. Stage 2 sulfur dioxide reacts with oxygen to form sulfur trioxide. Stage 3 sulfur trioxide combines with concentrated sulfuric acid to form oleum, H2S2O7. Stage 4 oleum reacts to form concentrated sulfuric acid. In stage 1, iron pyrites, Fe2, can be used instead of molten sulfur. The iron pyrites is heated strongly in air. Balance the equation for the reaction occurring when iron pyrites reacts with oxygen in the air. 6. Name Fe2O3. Include the oxidation number of iron. Iron 3 oxide 1. B. The equation for stage 2 is shown. The forward reaction is exothermic. The reaction is carried out at a temperature of 450 degrees Celsius and a pressure of 2 atmospheres. Using explanations that do not involve cost. 6b. Explain why a temperature greater than 450 degrees Celsius is not used. Yield of SO3 is less 1. 6b. Explain why a pressure lower than 2 atmospheres is not used. Yield of SO3 is less. OR. Rate is less. 6c. When sulfuric acid reacts with ammonia, the salt produced is ammonium sulfate. Write the symbol equation for this reaction. M1NH4 2SO4 on the right 1. M2 equation correct 1. 6d. Lead 2 sulfate is an insoluble salt. Lead-2 sulfate can be made from aqueous ammonium sulfate using a precipitation reaction. Name a solution that can be added to aqueous ammonium sulfate to produce a precipitate of lead-2 sulfate. Lead-2 nitrate. 6De. Write an ionic equation for this precipitation reaction. Include state symbols. M1PbSO4 on the right 1. M2 only Pb2 plus and SO42 on the left 1. M3AQ plus AQ right pointing arrow S1. 6De. The precipitate of lead-2 sulfate forms in an aqueous solution. Describe how pure lead-2 sulfate can be obtained from the mixture. M1 filter 1. M2 wash the residue or lead sulfate with distilled or deionized water 1. M3 description of drying 1. 0620_S23_Ms_42. 3. Over 200 million tons of sulfuric acid are manufactured every year. A. State the name of the process used to manufacture sulfuric acid. Contact process 1. 3b. Part of the manufacture of sulfuric acid involves converting sulfur dioxide to sulfur trioxide. Describe two methods by which sulfur dioxide is obtained. M1 burning sulfur in air. M2 roasting sulfide ores in air. 3b. The conversion of sulfur dioxide to sulfur trioxide is a reversible reaction which can reach equilibrium. M1 The rate of forward reaction equals the rate of the reverse reaction. M2 Concentrations of reactants and products are constant. 3b. State the typical conditions and name the catalyst used in the conversion of sulfur dioxide to sulfur trioxide. Temperature 450 OC. Pressure 200 kPa. Catalyst vanadium V oxide. 3b. IV Complete Table 3.1 to show the effect, if any, when the following changes are applied to the conversion of sulfur dioxide to sulfur trioxide. The forward reaction is exothermic. Only use the words increases, decreases or no change. 3b. Explain in terms of collision theory why reducing the temperature decreases the rate of the forward reaction. M1 Kinetic energy of particles decreases. M2 Frequency of collisions between particles decreases. M3 Lower percentage proportion fraction of collisions particles have energy greater than equal to activation energy. OR. Fewer of the collisions particles have energy greater than equal to activation energy. 3c. Sulfuric acid contains SO42 ions. The oxidation number of O atoms in SO42 ions is -2. Determine the oxidation number of S atoms in SO42 ions. Show your working. M1 4x2 or 8. M2s plus 4x2 equals -2 therefore S equals +6. 0620_S23_Ms_43. 6. This question is about nitrogen and compounds of nitrogen. Ammonia is manufactured by the reaction between nitrogen and hydrogen in the Haber process. The equation is shown. 6a. State the source of nitrogen for the Haber process. Air. 6a. State the source of hydrogen for the Haber process. Methane. 6a. State the typical conditions used in the Haber process. Temperature. M1450 degrees C. Pressure. M2200 atm. 6a. IV. Name the catalyst used in the Haber process. Iron. 6a. State what is meant by the term catalyst. M1 A substance which increases the rate of a reaction. M2 remains unchanged at the end of the reaction. 6b. Ammonia is converted into nitric acid. The first stage is the conversion of ammonia into nitrogen monoxide, NO. The equation is shown. The reaction is carried out at a temperature of 900 degrees Celsius and a pressure of 7 atmospheres. The forward reaction is exothermic. Using explanations that do not involve cost. Explain why a temperature less than 900 degrees Celsius is not used. Temperature change. M1 Low rate of reaction. Explain why a pressure greater than 7 atmospheres is not used. Pressure change. M2 Position of equilibrium shifts to the left-hand side towards reactants. 6b. In the second stage, nitrogen monoxide reacts with water and oxygen to produce nitric acid. Balance the symbol equation for the reaction. 6c. A student makes aqueous copper 2 nitrate by adding an excess of solid copper 2 carbonate to dilute nitric acid. I write the symbol equation for this reaction. M1Cu number 3 2. M2 correct equation. 6Ce state 2. Observations that indicate the copper 2 carbonate is in excess. M1 undissolved solid. M2 effervescence stops on addition of more copper 2 carbonate. 6De name one compound, other than copper 2 carbonate, that can be added to dilute nitric acid to produce aqueous copper 2 nitrate. Copper 2 oxide or copper 2 hydroxide. 0620M23_Ms_42. 3. The Haber process is used to manufacture ammonia. State the main source of each gas used in the Haber process. Nitrogen, air 1. Hydrogen, methane 1. 3b. The equation for the Haber process is shown. 3b. The reaction is reversible. The forward reaction is exothermic. State what is meant by the symbol increment H. Enthalpy change. 3be. Increment H for the forward reaction is -92 kJ per mole. State why this value shows that the forward reaction is exothermic. The value of delta H is negative. 3be. State the typical conditions and name the catalyst used in the Haber process. Temperature, M1451. Pressure, M220001. Catalyst, M3 iron 1. 3b. Complete table 3.1 to show the effect, if any, when the typical conditions in the Haber process are changed. Use only the words increases, decreases or no change. Less than, ans. 3b. Explain in terms of collision theory why increasing the temperature increases the rate of the reaction. M1 kinetic energy of particles increases 1. M2 frequency of collisions between particles increases 1. M3 higher percentage proportion fraction of collisions particles have energy greater than equal to activation energy 1. Or more of the collisions particles have energy greater than equal to activation energy. 3c. Ammonia reacts with an acid to form ammonium sulfate, NH4 2SO4. State the formula of the acid used. 3ce. State one use of ammonium sulfate. Fertilizer. 3ce. Calculate the percentage composition by mass of nitrogen in NH4 2SO4. M1 Mr of equals 132 1. M2 214 equals 28 and %N equals 128 130 seconds equals 21.2% 1. 0620_W22_Ms_41. 3. Ammonia is made in an industrial process starting with nitrogen. The equation for the reaction is shown. Name the industrial process used to make ammonia. Haber process. 3b. State the raw material from which nitrogen is obtained. Air. 3c. State what is meant by the symbol. Rightwards harpoon over leftwards harpoon. Reversible. 3d. State the temperature and pressure used in this industrial process. Temp. 451. Pressure. 201. 3e. Name the catalyst used in this industrial process. Iron Fe. 3f. The forward reaction is exothermic. State the effect, if any, on the position of the equilibrium when the following changes are made. Explain your answers. Reduced temperature. M1 position of equilibrium moves to right-hand side 1. M2 reaction is exothermic 1. Reduced pressure. M3 position of equilibrium moves to left-hand side 1. M4 more gaseous moles on left-hand side 1. 3g. Explain, in terms of particles, what happens to the rate of reaction when the temperature is reduced. M1 rate decreases and particles have less energy 1. M2 less collisions between particles occur per second per unit time 1. M3 less of the particles collisions have energy equal to or above the activation energy 1. Or less of the particles collisions have sufficient energy to react. Or a lower percentage proportion fraction of collisions of particles are successful. Or have energy equal to or above activation energy. 3h. Give the formula of the compound formed when sulfuric acid reacts with ammonia. 0620_W22_Ms_42. 3. Sulfuric acid is manufactured by an industrial process. Sulfur is obtained from sulfur-containing metal ores. The sulfur in the metal ore is converted to sulfur dioxide, which is then oxidized to sulfur trioxide as shown. A. Name a metal ore which contains sulfur. Zinc blende. 3b. Describe the process which converts metal ores to sulfur dioxide. Strong heating in air, roasting in air. 3c. Name the industrial process used to manufacture sulfuric acid. Contact. 3d. The reaction that produces sulfur trioxide is an equilibrium. The forward reaction is exothermic. I. State the temperature and pressure used to make sulfur trioxide. Temperature equals M1450 degrees C 1. Pressure equals M212 atm 1. Catalyst equals vanadium V oxide. 3d. Describe two features of an equilibrium. M1 The rate of forward reaction equals the rate of the reverse reaction 1. M2 Concentrations of reactants and products are constant 1. 3d. State the effect, if any, on the position of equilibrium when the following changes are made. Explain your answers. Increased temperature. M1 Position of equilibrium moves to left-hand side 1. M2 Reaction is exothermic 1. Increased pressure. M3 Position of equilibrium moves to right-hand side 1. M4 More gaseous molecules on left-hand side 1. 3d. Explain, in terms of particles, what happens to the rate of reaction when the temperature is increased. M1 Rate increases and particles have more energy 1. M2 More collisions between particles occur per second per unit time 1. M3 More of the particles collisions have energy equal to or above the activation energy 1. Or more of the particles collisions have sufficient energy to react. Or a higher percentage fraction of collisions of particles are successful have energy equal to or above activation energy. 3e. Name the compound formed when sulfuric acid reacts with ammonia. Ammonium sulfate. 0620-W22_Ms_43. 4. This question is about compounds of phosphorus. Gaseous phosphorus V chloride decomposes into gaseous phosphorus 3-chloride and gaseous chlorine. When the three gases are present in a closed container, the system reaches equilibrium. I complete the table using only the words increase, decrease or no change. Less than, ANS. 4ai. The table shows that when the temperature increases, the equilibrium yields of PCl3G and Cl2G increase. State what conclusion can be made from this. Forward reaction is endothermic 1. 4b. Complete the dot and cross diagram to show the electron arrangement in a molecule of phosphorus 3-chloride, PCl3. Show outer shell electrons only. M1 3 dot and cross bonding pairs 1. M2 all lone pairs correct. All octets should be complete and dots and crosses should be different on P and all Cl 1. 4c. Phosphorus oxychloride has the formula POCl3. Phosphorus oxychloride is the only product of the reaction between phosphorus V chloride, PCl5, and phosphorus V oxide, P4O10. Write a chemical equation for the reaction between phosphorus V chloride and phosphorus V oxide. M1 all formula correct and on the correct sides of the arrow 1. M2 equation fully correct 1. 4d. Compound X has the following composition by mass. Calculate the empirical formula of compound X. Empirical formula equals M1H3, 66/1, P37, 80/31, O58, 54/16. ORH equals 3.66 P equals 1.220 equals 3.66. ORH cheeky smiley face shocked face 3, 1, 3, 1. M2H3PO3 1. 4e. Compound Y has the empirical formula H3PO4 and a relative molecular mass of 98. Deduce the molecular formula of compound Y. Molecular formula equals H3PO4 1. 5. This question is about sulfuric acid, H2SO4, and salts that can be made from sulfuric acid. A sulfuric acid is manufactured by the contact process. Stage 1 molten sulfur burns in air to produce sulfur dioxide. Stage 2 sulfur dioxide reacts with oxygen to form sulfur trioxide, SO3. Stage 3 sulfur trioxide reacts with concentrated sulfuric acid to form oleum, H2S2O7. Stage 4 oleum is converted into sulfuric acid. The equation for the reaction in stage 2 is shown. State the temperature and pressure used in stage 2. Name the catalyst used in stage 2. Temperature M1450 1. Pressure M212 Catalyst M3 vanadium V oxide 1. 5 Write the chemical equation for the reaction in stage 3. 5 Name the substance that reacts with oleum in stage 4. Water. 5b Name the black solid that is produced when concentrated sulfuric acid is added to sugar, C12H22O11. Carbon. 5c Dilute sulfuric acid and aqueous potassium hydroxide are used to make aqueous potassium sulfate. The method includes use of the following apparatus. Calculate the volume of 0.0625 moles per cubic decimeter dilute sulfuric acid, H2SO4, that completely reacts with 25.0 cc of 0.100 moles per cubic decimeter potassium hydroxide, Co, to produce aqueous potassium sulfate. Dilute sulfuric acid and aqueous potassium hydroxide are used to make aqueous potassium sulfate. 5ce The experiment is repeated using the same volume and concentration of potassium hydroxide and the same concentration of dilute sulfuric acid. In this second experiment, the product is aqueous potassium hydrogen sulfate, KHSO4. Use your answer to Ci and the equation to deduce the volume of H2SO4 required. 40. 5d Aqueous potassium hydrogen sulfate, KHSO4Aq contains the ions K plus Aq, H plus Aq, and SO42Aq. Describe the observations in the following tests. A flame test is carried out on aqueous potassium hydrogen sulfate. Lilac flame. 5de Solid copper 2 carbonate is added to aqueous potassium hydrogen sulfate. Ne2 from solid disappears. Blue solution. Bubbles effervescence fizzing. 5de An acidic solution containing aqueous barium ions, Ba2 plus Aq, is added to aqueous potassium hydrogen sulfate. White precipitate. 5e Write the ionic equation for the reaction in De. Include state symbols. M1BaSO4 on the right 1. M2 only Ba2 plus and SO42 on the left 1. M3 state symbols 1. 0620S22_QP_41. 4. This question is about compounds of sulfur. Sulfuric acid, H2SO4, is manufactured using the contact process. This manufacture involves 4 stages. Stage 1 Molten sulfur burns in air to produce sulfur dioxide. Stage 2 Sulfur dioxide reacts with oxygen to form sulfur trioxide. Stage 3 Sulfur trioxide combines with concentrated sulfuric acid to form oleum, H2S2O7. Stage 4 Oleum reacts to form concentrated sulfuric acid. 4a Write a chemical equation for the reaction occurring in stage 1. 4a State the essential conditions that are necessary for stage 2. Write an equation for the chemical reaction that occurs. Temperature 450 degrees Celsius 1. Pressure 1 to 2 atmospheres 1. Vanadium V oxide catalyst 1. 4a Write a chemical equation for the reaction occurring in stage 3. 4a Name the substance that reacts with oleum in stage 4. Water. 4b Hydrogen sulfide has the formula H2S. Complete the dot and cross diagram to show the electron arrangement in a molecule of hydrogen sulfide. Show outer shell electrons only. 2 bonding pairs as 1 dot and cross each 1. 2 lone pairs on S and no additional electrons on H's to complete the outer shell on S and both H's 1. 4b Balance the chemical equation for the reaction of hydrogen sulfide with sulfur dioxide shown. 0620W21_Ms_41. 4-chalcopyrite, Fe+2, is used in the manufacture of sulfuric acid in the contact process. In the first stage of the process, chalcopyrite reacts with oxygen in the air to produce sulfur dioxide, SO2, iron 3 oxide and copper 2 oxide. Complete the chemical equation for the reaction of Fe+2 with oxygen. Equation fully correct 1. 4b. Sulfur dioxide is then converted to sulfur trioxide. The reaction is exothermic. It is also an equilibrium. State two features of an equilibrium. M1 rate of forward reaction equals rate of reverse reaction 1. M2 concentration of reactants and products are constant 1. 4b. State the temperature and pressure used in this reaction. Include units. Temperature, M1450 degrees Celsius 1. Pressure, M2 2 atm 1. 4b. Name the catalyst used. Vanadium V oxide 1. 4b. Explain why a catalyst is used. Increase rate of reaction 1. 4b. Describe and explain, in terms of equilibrium, what happens when the temperature is increased. M1 equilibrium shifts to left-hand side 1. M2 forward reaction is exothermic 1. 4 concentrated sulfuric acid is a dehydrating agent. When glucose is dehydrated, carbon and one other product are formed. Complete the equation to show the dehydration of glucose, C6H12O6. 0620_W21_Ms_42. 4-chlorine reacts with carbon monoxide to produce phosgene gas, Cocl2G. A catalyst is used. The reaction is exothermic. Explain why the reaction is exothermic in terms of the energy changes of bond breaking and bond making. M1 of making bonds greater than breaking bonds. M2 bond making releases energy. M3 bond breaking requires energy. 4b. Complete the energy level diagram for this reaction. On your diagram show, filled circle the product of the reaction. Filled circle an arrow representing the energy change, labeled increment H. Filled circle an arrow representing the activation energy, labeled A. M1 exothermic mark horizontal line below energy level to RHS of reactants line and labeled 1. M2 activation E mark activation energy, hump, with upward arrow labeled A activation energy 1. M3 energy change mark 1 downward arrow labeled delta H and energy change starting from E level of reactants and finishing at E level of products 1. 4b. State why a catalyst is used. Increases rate of reaction 1. 4c. Describe and explain the effect, if any, on the position of equilibrium when the pressure is increased. Equilibrium shifts to right-hand side 1. Fewer moles of gas on right-hand side 1. 4c. The temperature is increased. Equilibrium shifts to left-hand side 1. Forward reaction is exothermic 1. 4d. The reaction between chlorine and carbon monoxide can be represented as shown. When 1 mole of chlorine reacts with 1 mole of carbon monoxide, 230 kilojoules of energy is released. Some bond energies are shown in the table. Use the information to calculate the energy of the bond between the C and the O in carbon monoxide, Colorado. 4e. Complete the dot and cross diagram to show the electron arrangement in a molecule of Cocl2. Show outer electrons only. M1 all single bonding dot and cross pairs correct. M2 double C equals O bond dot and cross pairs are correct. M3 complete diagram is correct. 0620_S21_Ms_41. 4-dinitrogen tetroxide, N2O4, decomposes into nitrogen dioxide, NO2. The reaction is reversible. A gas syringe containing a mixture of dinitrogen tetroxide and nitrogen dioxide gases was sealed and heated. After reaching equilibrium, the mixture was a pale brown color. State what is meant by the term equilibrium. The rate of forward reaction equals the rate of the reverse reaction 1. Concentrations of reactants and products are constant 1. 4b. The plunger of the gas syringe is pushed in. The temperature does not change. The mixture initially turns darker brown. After a few seconds the mixture turns lighter brown because the equilibrium shifts to the left. Explain why the mixture initially turns darker brown. Explain why the mixture initially turns darker brown. Increased pressure, nitrogen dioxide particles or molecules forced closer together. Same number of nitrogen dioxide particles or molecules in a smaller volume. 4b. Explain why the position of equilibrium shifts to the left. Fewer number of gas moles or molecules on left-hand side or reactant side of the equation. 4c. The forward reaction is endothermic. I. State what happens to the position of equilibrium when the temperature of the mixture is increased. Shifts to the right. 4. C. State what happens to the rate of the forward reaction and the rate of the backward reaction when the temperature of the mixture is increased. Rate of the forward reaction increase faster 1. Rate of the backward reaction increase faster 1. 0620_W20_Ms_41. 3. Aqueous ammonium sulfate, NH4(2SO4), is warmed with aqueous sodium hydroxide. The pungent-smelling gas ammonia, NH3, is produced. Balance the equation for this reaction. 2. Right pointing arrow 2 plus 2. 3. A 2.8 grams sample of impure ammonium sulfate is found to contain 0.7 grams of impurities. Calculate the percentage of ammonium sulfate in this sample. Percentage of ammonium sulfate equals 75%. 3. C. Describe a test for ammonia gas. Test. Damp red litmus paper 1. Result. Litmus goes blue 1. 3. D. Ammonia gas is prepared at the front of a laboratory. The pungent smell of ammonia spreads throughout the laboratory slowly. I. Name the process that occurs when ammonia gas spreads throughout the laboratory. Diffusion. 3. D. Explain, using ideas about particles, why ammonia gas spreads throughout the laboratory. Particles move from an area of high to low concentration. Particles move randomly. 3. D. Explain why carbon dioxide gas, CO2, will spread throughout the laboratory at a slower rate than ammonia gas, NH3. CO2 molecules are heavier than NH3. 1. 3. Ammonia is produced in the Haber process. The equation for the reaction is shown. In the Haber process, a temperature of 450 degrees Celsius and a pressure of 200 atmospheres are used in the presence of finely divided iron. A larger equilibrium yield of ammonia would be produced if a lower temperature and a higher pressure are used. Explain why a lower temperature and a higher pressure are not used. Lower temperature, rate of reaction slower 1. Higher pressure, expensive specialist equipment. 3. State the role of iron in the Haber process. Catalyst. 3. Ammonia is a weak base. Explain the meaning of the term base. Proton acceptor. 3. Suggest the pH of aqueous ammonia. Any value greater than 7 up to 12. 0620_S20_Ms_42. 3. Sulfuric acid is made from sulfur in a 4-stage process. Stage 1 sulfur is converted into sulfur dioxide. Stage 2 sulfur dioxide is converted into sulfur trioxide. Stage 3 sulfur trioxide is converted into oleum. Stage 4 oleum is converted into sulfuric acid. How is sulfur converted into sulfur dioxide in stage 1? Heat in air. 3. Describe how sulfur dioxide is converted into sulfur trioxide in stage 2. Your answer should include filled circle an equation for the reaction. Filled circle the temperature used. Filled circle the name of the catalyst used. 3. The reaction in stage 2 can reach equilibrium. What is meant by the term equilibrium? Rate of forward reaction and rate of backward reaction are equal 1. Concentrations of reactants and products are constant 1. 3. Sulfur trioxide is converted into oleum, H2S2O7, in stage 3. What is sulfur trioxide reacted with to convert it into oleum? Concentrated sulfuric acid 1. 3. Oleum is converted into sulfuric acid in stage 4. Write a chemical equation for the conversion of oleum, H2S2O7, into sulfuric acid. 3. When copper is reacted with hot concentrated sulfuric acid, sulfur dioxide gas is formed. Balance the chemical equation for this reaction. 3. Sulfur dioxide is a reducing agent. Give the color change that occurs when excess sulfur dioxide is bubbled into acidified aqueous potassium manganate 7. Purple to colorless 1. 3. When sulfuric acid reacts with ammonia, the salt produced is ammonium sulfate. Write the chemical equation for this reaction. 3. Barium sulfate is an insoluble salt. Barium sulfate can be made from aqueous ammonium sulfate using a precipitation reaction. Name a solution that can be added to aqueous ammonium sulfate to produce a precipitate of barium sulfate. Barium nitrate, barium chloride 1. 3. Write an ionic equation for this precipitation reaction. Include state symbols. Formulae 1. State symbols 1. 0620_W19_Ms_41. 2. A sulfur exists as a number of different isotopes. What is meant by the term isotopes? Atoms with same number of protons or atoms of the same element or atoms with same atomic number 1. Atoms with different number of neutrons or atoms with different mass number or atoms with different nucleon number 1. 2. B. A sulfide ion has the symbol shown. I. How many neutrons are contained in this sulfide ion? 18. 2. B. E. How is a sulfide ion, S2, formed from a sulfur atom? Gain of 2 electrons. 2. B. E. Which element forms an ion with a 2+ charge that has the same number of electrons as a S2 ion? C. A. Calcium. 2. C. The manufacture of sulfuric acid by the contact process occurs in 4 stages. Stage 1. Molten sulfur is burned in air to produce sulfur dioxide gas. Stage 2. Sulfur dioxide is reacted with oxygen to form sulfur trioxide. Stage 3. Sulfur trioxide is combined with concentrated sulfuric acid to form oleum, H2S2O7. Stage 4. Oleum is added to water to form sulfuric acid. I complete the chemical equation for Stage 1 by adding the appropriate state symbols. L, G, G. 2. C, E. Name the catalyst used in stage 2 and state the temperature used. Vanadium V oxide or vanadium pentoxide 1. 450 degrees C 1. 2. C, E. Write chemical equations for the reactions in stage 3 and stage 4. 2. D. Sulfur dioxide is a toxic gas. State 1 environmental reason why sulfur dioxide should not be released into the atmosphere. It causes acid rain 1. 2. D. E. Describe the test for sulfur dioxide. Test aqueous potassium manganate 7 1. Purple to colorless 1. 2. E. Sulfur dioxide reacts with aqueous sodium sulfite to produce a compound with the following composition by mass: 29.1% Na, 40.5% S and 30.4% O. Calculate the empirical formula of this compound. 0620_W19_Ms_42. 3. Ammonia is an important chemical. Ammonia is manufactured by the Haber process. The reaction is reversible. What is the sign for a reversible reaction? Rightwards harpoon over leftwards harpoon 1. 3. State the essential conditions for the manufacture of ammonia by the Haber process starting from hydrogen and nitrogen. Include a chemical equation to show the reaction which occurs. Pressure 100 to 300 atmospheres per atmosphere 1. Temperature in range 330 to 500 degrees Celsius 1. Iron catalyst 1. Species, N2 plus 3H2 rightwards harpoon over leftwards harpoon 2NH3 1. Fully correctly equation 1. 3. Name one raw material which is a source of the hydrogen used in the Haber process: water, steam or methane, natural gas. 3b. Ammonia is a base and reacts with sulfuric acid to form the salt, ammonium sulfate. What is meant by the term base? Proton acceptor. 3b. Name the industrial process used to manufacture sulfuric acid. Contact process. 3b. Write a chemical equation for the reaction between ammonia and sulfuric acid. Rest of the equation 1. 3c. When aqueous ammonia is added to aqueous iron 2 sulfate, a green precipitate is seen. This green precipitate turns red-brown at the surface. Name the green precipitate. Iron 2 hydroxide 1. 3c. Suggest why the green precipitate turns red-brown at the surface. Any 2 from it. Iron 2 hydroxide is oxidized to form iron 3 hydroxide oxide by iron 2 hydroxide reacting with air oxygen. 3c. State what happens when an excess of aqueous ammonia is added to the green precipitate. Green PPT remains. 3d. Ammonia reacts with oxygen as shown. Calculate the volume of oxygen at room temperature and pressure, in dm3, that reacts with 4.80 cubic decimeters of ammonia. 0620_W19_Ms_43. 6. This question is about sulfuric acid and substances that can be made from sulfuric acid. A sulfuric acid is a strong acid. What is meant by the term strong acid? Strong equals exists entirely as ions in solution, fully dissociated 100% dissociated in solution 1. Acid equals proton donor 1. 6b dilute sulfuric acid and aqueous sodium hydroxide are used to make aqueous sodium sulfate, Na2SO4AQ, or aqueous sodium hydrogen sulfate, NaHSO4AQ. The method includes use of the following apparatus. 50.0 cm3 6C aqueous sodium hydrogen sulfate, NaHSO4AQ contains the ions Na plus AQ H plus AQ and SO42AQ. Describe what you would see if the following experiments were done. A flame test was done on aqueous sodium hydrogen sulfate. Yellow flame 1. 6Ce solid copper 2 oxide was added to aqueous sodium hydrogen sulfate and the mixture was warmed. Solid dissolves disappears 1. Blue solution 1. 6Da test can be done to show the presence of SO42AQ by adding acidified aqueous barium chloride or acidified aqueous barium nitrate. State the observation that would show that SO42 is present. White precipitate 1. 6De write an ionic equation for the reaction that occurs if SO42 is present. Include state symbols. Correct ionic equation 1. State symbols 1.